We're ready. Let's do it. Okay. We can all laugh when he comes in later.
That's right. We can ask him where he's been. First off, let me ask the question, how many were here at our last meeting that we had back in September? Maybe let me rephrase that. How many were not here at that meeting? Okay, we've got a few of you that were not here. To kind of let you know what we're doing today, we're the representatives from NASA. Obviously, everybody's got their badges on. Our purpose in being here today is to do recruiting for our technician co-op program. Last time when we were here, we came out and gave some handouts to you. I'm going to review those very briefly for the benefit of the ones who were not here. I brought a team of people with me today. Let me introduce over here on the right-hand side, Mr. Jim Bell from Electronics Fab, Bud Southall and Jerry Nichols from Electrical Section, Mr. Otis Riggins and Ray Gregory from Electronics Research. In addition, we also have Gerald Miller from the electrical section as well, and Ed Yarrington and Bobby Fix from the tunnels and labs areas. I hope I got them right, guys. I did not hear about it. Okay. Let me go through this very quickly as to what we did last time, and I'm not intending to spend much time with this. I'll have a little handout for each one of you with the same information on it. For those of you who may have misplaced it last time or have forgotten some of that, I'll give you some additional information to it. Our co-op program is a program that we have you come out, you gain experience on the job, you receive training while you're out there, along at the same time while you're going through school. Normally we work you in the mornings, 7 till 11 in the morning, something like 7 or 7:30. You attend school on a full-time basis in the afternoons until you graduate. Now we're going to be changing that just a little bit. You do have to follow the curriculum outlined as is given to you by Cecil. You actually have to enter into an agreement with him. You have to apply through application forms, which we have here for you today, and we will provide you a physical when you come out there for this program. All of you will be entering. If you have got less than 30 up to 29 semester hours, you will enter at the rate of about $5.52 an hour. 30 hours or more, it'll be around $6 an hour. We'll pay for your tuition while you're out here on the condition that you sign contracts with us. At the time you complete the program, you agree to enter into our apprentice program. If not, then you pay back the money that's been paid to you for your tuition only. There are some requirements to go with that. You do have to pass all your classes with a grade of C or better. We do try to give you a selection, a choice in the selection of what you're going to go into. That's why these gentlemen are here today. I don't want to take a lot of time because I want them to have the chance to do most of the talking to explain to you what positions we have that are available. Our selection is based upon the choices which you have asked, your previous experience, and the grade point averages which you have in school. Some of you have got a lot more schooling than some of the others, so we have to consider all those factors. But we do want you to be aware that the final selection will be up to the center management as to where they want you to be. The program's divided into two main areas, mechanical technology, and I'm not going to go into each one of these. I think you've probably been reading ahead of me a little bit on behind me here. And the other areas that we have to do with electronics technology. You do have the same benefits as other government employees out there. You have your insurance, sick leave, and annual leave, and a retirement program that you're working towards. When you complete this program, it's our sincere hope that you will give consideration to going into the apprentice program that we have out there. It is a pointing upside down here. So 6-year apprentice program. Hello, Cecil. Okay. It's a 6-year apprentice program that we have out there. When you complete the co-op program, you have the opportunity of being converted non-competitively into the apprentice program. The 2 years that you spent as an a co-op will transfer over to the 6-year commitment that you have with the apprentice program, so you have 4 years left to go when you go into that program. I think you can see the salaries that we go through here. I'm not going to spend a lot of time with that again. The requirements for the apprentice program are very similar to what they are for the co-op program. You do have to maintain a 2.0 and a 4.0 scale. You have to abide by the agreements which we have there, and you do have a continued obligation agreement which you have to complete. Classes for the apprentice program, all your classes that you're taking out here right now are accredited courses through Thomas Nelson. The classes that we have, for the most part, are accredited also. In many cases, you'll be coming right back out here to take a number of classes in addition to what you've already had. Some of these classes are classes that we've had the school design for us. Some of these are what we call shelf classes, the ones that they have here at the school that we just feel that you have a need for. Upon completion of the program, we do have a formal ceremony wherein the center director gives you your certificates. You do receive 3 at the time that you graduate. The nice thing about the apprentice program is a little bit different from the co-op program. While you're in the co-op program, you're going to school on a full-time basis. You're working on a part-time basis. When you switch over to the apprentice program, you're going to school on a part-time basis and you're working full-time. So you do receive a full salary. We do pay for your tuition and books in the apprentice program as well. Class time does count as duty time, and we give you time to go to and from your classes, and we try to provide transportation for you to get to your classes as well. With that, our main purpose today was to come and tell you what types of positions that we have that are available, and then to let the gentleman that I have with me talk to you in reference to what those areas are. We do have 40 positions that we're looking for today. These are the areas that we're looking for. I will give you a handout on this so you don't have to write down exactly what these are. Can all of you read that? It's kind of hard to see, isn't it? Let's go this way. I've given you a little acronym in front of it over here that relates to the position that you would actually be asking for at the time that you apply. On your application forms, when you go through, I'll ask you to identify which one of these areas you're looking for. I'd like you to use that little ESB or ETB or electronics research, whatever it happens to be. Some way that I can know for sure exactly what your area of interest is. As you can tell, we have 15 positions that are open in the electrical or electronics areas that we're looking for. And in addition to that, we have 25 positions that we're looking for in the mechanical areas. With that, let me say that what we'd like to do at this point is to... Cecil, where's the other room that you're going to be having the people meet?
I think the electronics moved
To room 300?
to room 300.
Tom? 300? Okay. Okay, very good. With that, let me, what our plan is for while we're in here, what I'd like to do is to separate into 2 groups, with the electronics people going with Mr. Bell, South Hall, Riggins, and Gregory, and the mechanical group, Mr. Miller and Mr. Yarrington, will be working with those people as far as giving you information about the types of jobs that you'll have. What I would like for you to do while these gentlemen are talking to you is to take notes. Ask any questions that you've got at the end of the time, because we're going to ask you to make a decision as to where you would like to go into this program, what type of work you would like to do based on the information they give you today. So if you think of something that they don't ask you, please, by all means, say something. Raise your hand, get their attention, because we're going to ask you to make a decision. And it's going to be quick turnaround time on this. I'm going to be asking for applications back from you on Monday. Okay? So that's why you need to try to get as much information as you can today.
That's perfect.
No. That's
Thursday?
next Monday.
Next month.
Next Monday. My my time fuse has been shortened. My management has said that they need to have this information sooner. We were hoping to give you about a week, but in order for us to start processing on this, we've got to have it in a much quicker time frame. So you've got today, this weekend, and we'd like to try to have the applications back out here to school on Monday afternoon at the latest. To Mr. Phillips' office. Does everybody know where Mr. Phillips' office is? Okay. But I think we've got some good information for you today. You say the electronics people are going to go in room 300?
Right.
Everybody know where room 300 is? Okay, if the electronics people would like to go up there, and the mechanical people would like to stay in this area here, please.
Somewhere between 299.
Okay, so
Fred, I appreciate you getting started and going. I was hung up off campus, couldn't get back.
Well, I was afraid that we'd get some out, so if there's any mechanical back there, why don't you move on up to this section up here, please?
What we want to make sure of is that everybody that picks up an application signs it. I'll get a sheet so I can make sure that takes place. That way I can keep up with it.
Let me introduce to you Mr. Gerald Miller from Fabrication Division. He'll be talking to you. First off, did everybody get one of these forms here? Let me pass these out so that you'll know which areas he's involved with. And I'll start some from the other side as well. You passing out those? Yeah, I'm passing out that very same form right there so that they'll know which one that you're. If you would, just refer back to that as you're talking or let them know what the numbers are in each case. Let me pass these out as well in case there's someone who just asked. Let me go upstairs and get those guys going.
Fred said, my name is Gerald Miller. I was fortunate enough to be appointed to come out here today and give you some ideas of what we do in the mechanical area as far as model building and exactly what goes on as far as from the research area. A little background, I started an apprenticeship in 1963 and graduated from the NASA Apprentice School and elected to stay in the Fabrication Division, the Fabrication section my entire career. I've been out there 25 years and I just made the supervisor a couple of months ago of the section, and I thoroughly enjoy it. It was an opportunity for me to start out when I was real young and sort of mature with the organization. So I've been around there a long time and have seen some of the things that go on. I've been sitting out there wondering what I was going to do for a vocation in my life, and finally ran into NASA and decided to go through the apprentice school. It's worked great for me. What I'm going to do is just go over this administrative type things real quick so we can get to some of the hardware that we work on. That's why I'm in the business, and the section I'm in is in the business of producing spacecraft hardware, aero hardware, aeronautical hardware, wind tunnel models, and that sort of thing. And what we have out there, as far as, can everybody see that? We provide the technical support for design, development, and manufacture of aerospace research hardware, and that's prototype. we aren't in the business of production at all. No production. And NASA Langley, one of the many research centers that NASA has elected to stay a research center. The prototype is one-off type items. And we do build flight hardware, spacecraft, satellites, and this sort of thing. And prototype is something that's, taken from the drawing board to development in the shops that are right on site. We have on-site engineers, we have on-site technicians that perform this work where we end up with a product. Okay? We make test hardware and wind tunnel models. We have flight projects. We have flight aircraft that we use to perform experiments in flight. The Fabrication Division is composed of 5 organizations: Quality Assurance, Resource Contract Branch, Metals Application Technology, Models, Materials Technology, and Electronics Technology Branch. What I'm going to talk to you about is the metals applications and the models and materials technology. Before I start talking about all that, the type of environment you're going to be working in if you sign on with us in the Apprentice Program is basically inside in a building where you have controlled atmosphere, heating and air conditioning. We have up-to-date machinery and equipment to work with. We train the people, like if we hire young people like you, we train people in the field that we can use you in that section. In other words, you become broadly oriented with everything that goes on at Langley, but you have a specialty in where you're working. Like if you work in one of the shops, then you're going to be a specialist. You're going to be a machinist, or you're going to be a fabricator, and you're going to be an expert at it. The whole goal is to get you to be an expert as quick as possible so we can use your talents to produce this hardware. That's the people. Continual career training. We have all types of facilities, including using Thomas Nelson Community College as a training platform. We also deal with other colleges. We have on-site training. We have on-the-job training. We have cross-training where you go to other sections, learn what they're doing so you can relate back to what you're doing and they're doing, coordination. A dual career ladder. What that means is you do have the opportunity to not only go through the apprentice school, but you also have the opportunity to get in management if you want. You go through apprentice school, take the appropriate classes. You also have the opportunity to get into engineering. For instance, every year the graduating class has a top 1 or 2% that's eligible and can be selected to go into engineering. And if you're selected and your grades are that high, that's the selection point. The highest grades determine who goes to engineering school. You go out of your section, you go into engineering. So that's your career ladder. You have a choice. We have safety programs, of course. We try to follow all the federal regulations and conform with all the OSHA practices. The work areas that you work in will be laboratories, and even the shops are considered lab conditions. For instance, you may have painted tile floors and very clean working environments. None of the sweatshop type of atmosphere was 20 years ago on the outside. It's very controlled conditions and very, very nice working conditions. Of course, you have parking. It's not like driving down the Newport News shipyard and trying to park. Everybody parks where they work. In-house recreational activities are covered in the Activity Association. We have all kinds of clubs, anything you can think of. If you're in any of your interests, hobbies, or there's somebody at Langley Field that probably is into it that you can associate with. All right, the Metals Application Technology Branch. I got this divided into two shops. 2 sections, if you want to call them. They're shops. The Advanced Machining Development section has some of the most up-to-date numerical control, CNC machines and the like to perform all types of complex machining operations. That's the Advanced Machining Development section. That is a machine shop. I mean, one of the best one in the country. Machining NC, programming and processing, precision wind tunnel models. I'm going to show you some pictures of some of the models. I don't have a whole lot of time to spend on it, but I'm going to show you some pictures of some of the things that have been developed out there. Space flight projects and unique one-of-a-kind hardware. One thing I want to point out, between the shops, there's 5 shops. You know, I'm going to give you basic. There's a wood shop, there's a plastic shop, there's a metal shop, and there's a machine shop, and there's an electronic shop or electrical shop. Then amongst them you have foundries and a glass shop and all the supporting activities. There's enough expertise in those shops right there to build anything you can think of out of metal or wood or plastic. If you can dream it up, they can build it. If you wanted to build a car from the ground up, it could be produced right on site, right there. That's the kind of expertise that's available and the kind of training you're going to get. All right, that's Advanced Machining is one of the shops. The Metals Application Technology section is where I'm directly related, and I've been there for a long time. We're in the metal forming, welding, vacuum brazing, repair and modification of flight aircraft, space flight programs, repair to facilities. Now, not only are we responsible for, you know, when you take into account metal forming and welding and brazing, you take into account all the other shops too. You have to support as one of the shops. This shop supports us, we support them, and everybody works like a big team. All right, the repair and modification of the flight aircraft, like I said, we have flight aircraft that perform the experiments, that do some of the experiments. Actually, the experiments are on the aircraft and actually fly them. You have to repair these aircraft, modify them and so forth. Space flight program, we built satellites, and I have a picture of one of those. And repair to facilities, things like high pressure piping. Repairs to the boiler. Hey, the heating plant breaks down or something. Hey, you even get called in to repair steam lines sometimes. Okay? That all falls under this section. All right, this is one of the other shops right here, the materials processing and development section. It is not, there is not a position open in that section right now. I just want you to see that that's another one of the shops that they carry on the plastics and that sort of thing, polymers. The composites model section, which there is some positions open, deal with similar things that the metal fabrication shop deals with. Wind tunnel models, free flight radio control models, full-scale aircraft modifications, and also special surface coatings. Also your epoxies and all kinds of resins and this sort of thing, you know, and laminates. They build models out of all this sort of stuff. I can come back to some of this if there's questions. I can pull these back up. I'm going to move on as we can right now. But all right, here's, I don't know if you can see that. Mechanical Technology Branch. This is a model, looks like a ordinary plastic model or something you might buy at the drugstore. This is a new concept. Or it was a new concept. It was a wind tunnel model, completely machined out of solid, some type of metals. And the model was machined to some specifications that was engineered to fly in a wind tunnel, okay? They take a model like that, that model might be this big or it might be this big, you know, some scale of what they're trying to accomplish. They mount that model on a sting, which is just a rod that sticks in the back of the model, and they can control the attitude of the model in the wind tunnel. As the wind's passing over the model, they can control the pitch and yaw and turn it and everything like this in the wind tunnel, and they can see what effects the wind is having on the model. So these models could be 1/10 scale, 100 scale, or whatever. They're very precision, built within a millionth of an inch sometimes, that close of tolerance on them. This type of activity is generally carried out in the machine shop. This is the real precision type work that's done in there, among other things. This happened to be on the same view graph. The laboratory glass components, there is a glass shop where they blow glass, form and shape it. There's not a position open there, but the capability's there. A force measurement instrument, we call them balances. This balance is the type of thing that would go in the back of the wind tunnel model. While the wind tunnel model's in the tunnel, this balance sends readings back to your control panel and your observation deck, where you can actually see the forces being put on that model. That's a real rough explanation. But instruments like that are built out there. The actual instruments are developed and installed in the models to do the readings. Okay? This here is a cryogenic tunnel rotor fan. That could have been machined out of a piece of metal. It could have been fabricated and welded. That one there happened to be machined. There is two cryogenic tunnels out at Langley, and that's, you know, the very cold atmospheric tunnels. All right, here's a machine piece, for example, that was built or machined in the machine shop. Some of the positions are in that section. This part here was maybe 4 inches across. This is the blown up view of it. It was used on the shuttle step pallet simulator, which is simulated the internal location of the experiments in the shuttle bay. In other words, we mounted, this is one of the mounts. I just brought that along to show you the type of machine work that's being done. Now this is a model. That was probably 15 feet long. It was done in the fabrication shop, all that sheet metal. And you coordinate models like that between the shops. You have sheet metal on the outside, and you had fiberglass edges, fiberglass or wood parts that mounted on it. So it takes the coordination of two shops. And when you coordinate two shops, you have one shop that's the lead shop, and you have another shop that supports you. So if most of the work is sheet metal work, the lead shop is a sheet metal shop. And then the model shop supports you. And then somewhere on there is probably some machine parts too. So you have their support. But you work together. Here's another model. Again, machined out of a solid piece of material. Assembled and used to do a test in the wind tunnel. Here's a picture of a spinning lathe. There's the operator. Spinning lathe, that's located in the sheet metal shop. The metals technology and development section is the same thing. This is some items that were spun in that lathe. This is a picture of the space structures research, which is in full swing right now. We're trying to develop a space station, and I guess it's in the news and everything. NASA is trying to put a space station up in orbit, and there's still a lot of research being done on how to put that together and how big it should be and what type of members are in it and that sort of thing. And that was one of the experiments there to try the application, to see how to assemble it. One of the preliminary applications. All right, this is a research facility support. Now this is it says research facility support. That means probably some of the people in the metals technology section went over there and applied their expertise to get a job done in one of the wind tunnels or one of the test labs or something like this. You get to support them. We're in the business of supporting. What we want to do in the shops is be able to provide the researchers with hardware that they ask for. that they design to do their experiments. So we're like a support business, you might say. And the people that use our hardware are the researchers that are conducting these experiments. Basically, we build what they tell us to build. That's a vacuum brazing furnace. There's a model in there being brazed together. Vacuum brazing is simply, I'm going to give you a real simple definition. It's a furnace. You put two pieces of metal in a furnace and you put some type of braze alloy between them, a thin sheet of braze alloy. You heat it up to some temperature that the braze alloy melts inside this furnace there's no air in there. And when it gets to a certain temperature, the braze alloy melts and those two pieces of metal are bonded together. The advantages are there's no oxygen, there's no voids in the braze. So you have a good bond. Here's two technicians working on a model. That's in the machine shop section. Okay, that's probably a wing. Now here's a flight model that was done. This is an aircraft here, right? The wingtip was modified. Had this star put on the end of the wingtip. The whole purpose of that experiment was to be able to control the vortex coming off of commercial aircraft, for instance, landing at an airport, because the vortex that comes off a commercial airplane is like a small tornado off of each wingtip. When a commercial aircraft comes into land, you have two of them right behind the airplane, and a small Piper Cub comes along, flies in that vortex, and it's crashed. So that was a study to help determine where the vortex was, how to eliminate it, how to control it, this sort of thing. Flight project. Here's another aircraft we modified in the sheet metal shop, Metals Technology section, MTDS. This what it was an aircraft that had propeller engines on it, and we converted it to jet engines. Took the aircraft, brought it in the shop, took the old engines off, put the jet engines on it, took it to the full-scale wind tunnel, and they flew it in the wind tunnel, and they got data off of it. When I say they fly it in the wind tunnel, they mount it on a control arm or a sting in the wind tunnel. They blow air by it, start the engines up, and actually run the thing. So that's full-scale aircraft modification. In fact, we just finished modifying a F-106B fighter aircraft. It's an old fighter plane, but we completely modified the leading edge of the swept wings of the airplane, modified the whole shape of the leading edge to make the plane more maneuverable. That's the type of work you get into. Of course, that's a picture of the space shuttle. And that satellite right there was built in the Metals Technology section. This being a satellite, that's the arm that retrieves the thing. That satellite had numerous experiments. Each one of those squares was a different experiment from different colleges, universities, and NASA. And well, it's been up there several years now. It was not retrieved at the time they expected, but it is going to be retrieved next year. And I'm sure that there's some data that's going to be obtained from retaining that satellite. That satellite was fit right in the shuttle bay. It was like 15 feet by 30 feet long and put into space, and then those experiments, orbited the Earth. It's orbiting the Earth, and they'll retrieve it, bring it back, examine it, and get data from the experiments that were done. Okay, we still do that. We still build flight hardware to go into space. All right, here's the fabrication division technicians, and that's what you'll be. You'll be technicians in the fabrication division. And fabrication means you build things out of, in this case, all types of materials. And we consider it a team effort. A working relationship between the researcher and the engineer and the technician. The engineer basically is a person who gets ideas from a researcher who has a basic idea. The engineers break it down into components, they draw them up, and they bring these drawings to us, and we build what they draw. Okay? So to get all those three to working together, the technician has the opportunity to interface with the engineer and even the researcher to make sure they're getting what they want. Makes a technician an important part of the design and decision-making process. And after you gain experience, the engineers look to you for your practical experience. You have experience in how things go together that they didn't learn in school. You learn it on the job with the guys that have been there 25, 30 years. They come to you sometimes and say, hey, what's the best way to do this? Is it easier to do it this way or that way? The technician independently plans and coordinates manufacture from start to completion, and that's manufacture of the part you received your drawing packet from. In other words, you receive a drawing set and you're supposed to produce what's there. You have control over drawing the material to build it. You have control over how it goes together. You can coordinate how it goes together. You can ask for help from the other sections, other shops. And seeing result, the job satisfaction. If you enjoy seeing something go together and you're mechanically inclined, you definitely should be mechanically inclined to get in one of these shops. Not joking about that. But when you see something go together and be built by your hands, you have the satisfaction of knowing that you built it and it has a purpose and you know where it's going and you know it's going to be a test and what it's going to do. All right, communications, discussing work requests and problem areas. That goes back to your engineering and your researcher. Communication is important. There's a lot, it's not all written, a lot of verbal communication out there. Decision making, deciding methods, techniques, and processes to use. That's back. After you're there a while and you go through the apprentice school, you're there for your whole time that you finish Thomas Nelson, you get all your academics done, and then as you put your time in on the job, you learn what you're supposed to be doing, and you're able to have the self-assurance that you know what type of operation is supposed to be performed to get what results. Technical ideas, design recommendations, like I went over that. Cost and schedules, making realistic estimates. Sometimes you're asked to make an estimate of how long. This is after you have some experience. You're asked for, hey, how long, the supervisor might ask you, how long will it take you to make that? Hey, you give it your best shot, right? Use of resources, allocation, plan effective use of resources. Self-explanatory. Documentation, keeping records of your project. Coordination and monitoring, staying on top of your work tasks. The assembly. Assurance the end product meets all required specifications, and that's part of record keeping too. So it's pretty good. It's a good program. When you come in, we take new trainees, we put them with old experienced guys, just like the old apprentice school was. Take the new guys, put them with the old guys teach the new guys, and you keep circulating your personnel around amongst experienced people until they have all the experience that's there. Any questions? Did I go too fast?
I'll give you a chance to ask any questions.
Well, I do have one question. You said one of the things done was non-destructive testing.
Yes.
In that department, I think the other department, the labs, also does that too, doesn't it? Or is that just your? Because I'm just trying to figure out who.
We had
I'm
one.
interested in that.
We have a materials processing section which doesn't have a position open now that takes care of the non-destructive testing. They do X-rays and dye penetrant and all that. They support us. You know, they support. You do a weld and you want to check it out. There's several ways to check out whether a weld is good. X-ray, dye penetrant. If it's a ferrous metal, then you can magnetic particle check it. This sort of thing. You know, so they take care of that.
Don't the labs do that also?
The labs are, you know, like a lab that has, does experiments per se. they're basically dependent on us and contract people to help them set up, or help supply them with material and hardware. Basically, the labs don't build their own hardware unless it's just small things. The experiments in the labs are basically wind tunnel technicians, is type of hiring that would be done there. I think Ed's going to talk about some of that, right, Ed?
Okay, that's one of these positions that are listed. There's only, the only departments open here are like sheet metal machinist and model maker. Does that mean you wouldn't be able to get anything else because that's all that's available now, or would you be able to move into the other things as they became available?
Basically, when you sign up for what you sign up today, you want to stay in that trade until you run through it. Now, there's some positions open in the labs, too.
Yeah.
But basically, you sign up with the machine shop, we want you to stay in the machine shop until you run through that apprenticeship and become a journeyman and become a useful asset. Yes, sir.
You said while you're going through apprentice school, you know, you could have different opportunities to study other career. I mean, you know, advancing. You say you could advance to an engineer. Some people do.
You can, yeah.
Is that? I mean, can you do that while you're going through the apprentice school and everything? Like,
Usually when you're going through the apprentice school, you have to be hard focused on your apprentice classes. And the way to get on into engineering is to keep your grades way up to the 4.0 area, because it's competitive. It's competitive to go from a technician area into an apprentice engineer. You have to be way up at the top of the class.
Would you have the same option to go to forward your education? Let's say if you weren't in that 4.0 range, say if you were in like the 3-point range and your grades were good and you wanted to eventually get on the engineer level, could you somehow still pursue that course?
Yes.
And you would supply the tuition in school and stuff like that?
Basically, we can support you in the section that I'm in, and most of the sections, that I think this is true. If you're going to apprentice school and there's other classes you'd like to take in addition to the classes you're taking, if they're job related, I'll back you 100%, and we can get the government to pay for it, pay for those classes, reimburse you for the class time if it's job related. Okay, after you get through the apprentice program and you want to go into engineering, they keep on paying you because then you go into engineering and then it's job related again, see? So it needs to be job related to qualify you for the class you want to take. But if you want to go on your own, we're fairly liberal on what is job related. You know, we try to give people, if people want training, we try to give them everything that we can, because, you know, it's important for everybody to especially give them the freedom to go ahead and get training, you know, especially if they want to. And try to support each individual's desire to either get academic training or get on-the-job training in other areas. I've had people request me, hey, can I go over to such and such a section and observe a particular operation? I think this would be good to know and all this. And spend a couple weeks over there. Yeah, that's good. But that's what we encourage that. In fact, we even had a program at one time set up for cross-training. We'll send the guy over to another section. And in fact, engineering still uses it. They'll take their engineers that have gone into engineering, that are in engineering, the young engineers, and they circulate them through all 5 shops, like 6 weeks at a time, so that this engineer can see how every shop works and what's required to get the job done. And that helps make a good engineer. You don't have somebody then that's just learned it out of a book. But flexibility, we try to stay flexible. We do want people to stay in the trade they start so we can use them in that trade. If they're so intelligent, though, it's better to have them in engineering, right?
Everybody get one of these.
Thanks, Jerry. Let me introduce to you Mr. Ed Yarrington. He's going to be covering the tunnels, labs, and mechanical support and utilities operations branch. We'll bring the others back in just a few minutes and kind of open it up for any general questions. Now, I glazed this super quick while ago, so I hope you take the time to look through it in detail.
Can we get the numbers right?
My name's Ed Yerington. I'm also an engineering technician. I moved up in the management ranks. I started out in Apprentice School in 1962, graduated in 1966, and I've been in wind tunnels operations my entire career. And sometimes I'm surprised I got paid for doing the fun things I've done. It's really been fun, been good to me. NASA's a great, great place to work. So what I'd like to talk to you about today is I'm representing Operations Support Division, OSD, and I'm going to be talking about 3 different branches, and each one of these branches are mechanically oriented. The first one is MSUOB, Mechanical Support and Utilities Operations Branch. I understand they're looking for 2 positions. And Tunnels Operations Branch, that's the one I'm in, we're looking for 8, and the Laboratories Operations Branch is looking for 6. So I've got a series of view graphs. Jerry did a good job on what we have, what kind of working environment, what we have to offer at NASA in general in terms of employee benefits and whatnot, so I'll not spend any time on that. Okay, first one is Mechanical Support and Utilities Operations Branch. And this is a group of technicians that are like 60 strong. And they work in areas of mechanical support where they install, modify, and maintain research industrial equipment. And you see a technician working on large motor bearings. They do work on the large drive motors, the bearings, the alignment, and this type of thing. Also in this mechanical support is a piping systems. The technicians in that group, they fabricate piping systems. They actually work with pipe. Now, this is not piping systems like a plumbing system in a house. These are research-oriented piping systems. Some are very exotic. They work with all kinds of metals, copper and such, and steel. Also conduct mechanical equipment preventive maintenance program. That's a big thing at Langley. It's one of the best in all the agency. It keeps our facilities operating, and technicians maintain. They make this program happen because they're the ones that make sure the safety switches work and the pressure switches are working, and the filters are changed, and this type of nature of work. Stop me anytime you have a question, anything you'd like to look into a little bit further. Also in this branch, they take care of utilities operations, and by utilities, we think of consumables such as air that we use in our wind tunnels, nitrogen, methane, the gases, argon, and helium. We've got some facilities that use helium. So utilities operations, these are representative of the control rooms in these various places where we distribute the air to the various facilities. This branch takes care of that. They also take care of the reclamation of helium. Helium is very, very expensive, and we use it in our wind tunnels, and we dump it into a sphere, and they take it out. They do all the operations of the machinery and the equipment that takes this free helium and puts it back in our storage vessel so we can use it again. So that's utilities operations. And finally, in that branch, there's a group that does fluid systems and hydraulic controls. And in it is, they take care of our automatic controls. A lot of our equipment is pneumatically controlled or hydraulically controlled. These technicians take care of that equipment. They keep it operational. They design some of these systems. They keep them tweaked up, keep them in top form. They perform calibrations on these various systems that support our wind tunnels. And again, this is research-oriented equipment. This isn't the normal shop equipment that you'd find in an industrial plant somewhere. These are research-oriented. These are things that basically what it amounts to is one of a kind. Some of these systems don't exist anywhere else in the world. And that's what's kind of exciting about working in OSD. We do some things that's never been done anywhere else in the world. And that's fun. So I'd like to talk now about the Laboratories Operations Branch. That's this one right here. And I understand they're looking for 6. And okay, here's the mission of the Laboratories Operations Branch. Provide efficient technical assistance and facilities operational support to research endeavors within the Langley research center community, maintain technical competence at the highest levels achievable, and assure timely, safe, and productive response to research goals. We in OSD and everyone I'm talking about, we are a service organization. Our job is to get the research that the researcher wants done, is to support him, and that's our main thrust. We work hand in hand with the researcher. When he is wanting our support, we're working hand in hand with him. And as Jerry said, in the shops, they often don't know how to do things, and as our technicians grow up and come up through the co-op and apprentice program and become technicians, they have the knowledge and expertise, and many times the researcher will come and ask, hey, how's the best way to do this? So we have that opportunity to do that. So I'd like to show you a series of view graphs of some of the types of work. Again, this is an LOB, Laboratories Operations Branch. This is a technician, apprentice graduate, and he's applying a strain gauge to a piece of test article. In this case, it's a helicopter rotor test. You can't see the helicopter in it. This is a technician doing a test in the background. You can't see it well because of the lighting, but it's a test on the shuttle's SRB, the solid rocket booster seal concept. We do a lot of work in support of the shuttle, and it's real-time work in support of Langley had a good piece in the fix on the shuttle, the problem they had when the Challenger. So we get involved in this real-time research. In fact, in the Laboratories Operations Branch, it was a technician, graduate apprentice, that had a big part in that solution of that problem. This is an apprentice. It's a female apprentice, and the females do very well at NASA. We've had some very, very pleased with that. They hold their own very good. Again, this is a technician and an apprentice. Again, a female apprentice. They're setting. This is a model that Jerry told you about a while ago. The model is on the end of a sting or support arm, and they're checking it out. They've assembled it, and this is a senior technician working with an apprentice. Here's a technician working in, you can't see it well, again, it's a laser setup in laboratories. They have a lot of laser. They're doing a lot of work in laser technology. All the folks you see in these pictures are all engineering technicians or apprentices, or in some cases co-ops. This is one of our noise chambers. It's called an anechoic chamber, I think it's called, and it absorbs all sound. This is really strange to work in this place if you've never been in one, because it absorbs all sound. It's a very, very eerie feeling in there. But this is a test on a dual propeller. This is an apprentice technician just making some final checks. Again, this is an apprentice developing a new material. What you can't see is suspended between these two arms. This is some type of test device, and that person's making the final checks or inspection of the material. Again, this here is a test on it's the SRB. It's a candidate material. It's a composite material that was fabricated somewhere, and this is a compression test. They're trying to squeeze it. And that's what they do a lot of this in Laboratories Operations Branch. They have a lot of these tests, just a second, a lot of these test equipment and test setups that push and pull and apply heat, and that they do a lot of this in labs. Yes?
I heard that, it was my understanding that the labs did do some non-destructive testing. Is that correct or not?
I'm not sure they do non-destructive testing. A lot of their testing is destructive. In other words, they will maybe, and I don't know about this one, but they may press this one until it does fail, but they want to know where it fails. So that's destructive testing in this sense. But what they don't do non-destructive testing like X-ray, or they don't do that.
They don't do machine, you wouldn't do much machine shop, would you, in that lab?
No, not in laboratories. We'll do, it's mechanically oriented. The heavy machine work is done by the shops. They make it, we break it, and then they fix it and we test it again. And I don't mean to be real funny. A lot of times in our research, and that's what's kind of exciting too, because we have tested something and it may fail, and that's, an answer like that is just as good as an answer that doesn't fail. So a lot of times the shops, they fix it up and we'll test it again. So sometimes that is part of our job. And his technician, again, you can't see much. He's working with some high energy switching technology, like in space. Let's see, the number of technicians in this branch is about 130, I believe, is technicians. Now, these technicians are scattered out in several facilities. I think there's 13 different facilities these technicians are scattered out in. So it's not working in a central shop. You'll be working in various facilities and you'll rotate. You'll work 6 months in one and 6 months in another. There's tremendous advantage to that because you get to see so many different research activities, and that's really exciting to see all the good things happening, and you get to meet a lot of people. This is an actual view in a control room and operations support division. That's what we're about, and operations of equipment and control panels is a very important part of our job. This is an interesting test. This is an apprentice near to graduation, and again, I wish you could see it better. This is actually a shuttle tire, and this is again real-time research. The shuttle was having the tires weren't lasting quite as long as they should, so we have a test facility that actually is called Landing Loads, and it actually tests a full-scale shuttle tire. What you're trying to do is for futuristic, trying to improve better tires, different type of runways. And again, operations of facilities and panels is one of our strong points. It's kind of exciting to operate in some of these tunnels because some of these facilities and labs, the test, it goes very fast. And the technician has really got to be on his toes to keep up with the events. And the technician is relied upon to operate and test, to perform the actual test. He may be directed by an engineer, but the technician does the work, does the test, and it kind of gets exciting when you know you're controlling thousands of pounds of pressures and energy and whatnot. It kind of gets exciting. You notice a lot of our panels have more than one operator. You'll see that again. Teamwork is a byword in OSD. One technician's got to know what the other technician is doing. This is another one of our tests in the laboratories. This is an actual scale model of a shuttle. And the array looks like pieces of yarn. What they were testing is an arresting system for a shuttle in case when it lands, in case everything else failed, the brakes failed, whatever. I mean, this is a last ditch resort. They were trying to come up with an arresting system so that it could go into it and it'd be something very elastic and would take all the energy and slow it down and stop it. And this was a test. This is the kind of things we do out there. It's something that's never been done before. Okay, any questions on either MSUOB or TOB before I go on?
You said TOB, you're going to go with the wind tunnel section?
Yes, that's the one I'm going to start in next.
I just wondered, they said most of these start at 7 o'clock. Is that true for the departments in this division?
Yes, it's most of the, I think MSUOB, I believe that group, they all start at 7. Bobby, help me with that. And I think they start at 7 and 7 to 3:30 normal shift. And then the tunnels vary. We normally respond to the researching organization. If the researchers, if they start at 7:30, then we'd like to start with them. We want to be there. But that's our job. We support them. We want to be there when they're there and we're needed. So we normally, there are 3 shifts, 7 o'clock shift, 7:30 shift, and 8 o'clock shift. Those are our normal shifts. There are other shifts. There's night shifts in some of the tunnels where we work second shift.
I was just wondering, because the students would be more convenient to work from 7 to 11 because we'd have an hour.
Yes.
To get back. Is that the way the students are going to be working?
Well, that's negotiable with the supervisor. It's never been a problem. Your training, your schooling is number one with us.
Yeah.
Your training is number one. So we're not going to do anything to get in the way of your schooling. If we need to adjust times or shifts or whatever, we'll do that. That will not be a problem.